understand the elementary combination of when the resistances they are in series. When we say resistances they are in series, so we mean by this, that is one after the other they are attached. That is, they are attached end to end. End to end they are attached. That is, when the current flows through this circuit, when the current comes over here, this is like a pipe in which the current is flowing. Obviously, when the current flows through it, the same current shall be flowing from all these resistors which are connected in series, which are connected end to end. So you can also take it like this is a water pump. So this water pump is what is doing? It is a source of energy. It is not creating water. Similarly, this battery is not a source of charges. This is a source of energy. This pushes the charges into the circuit, comes over here, once again gives it energy and throws it back into the circuit. So this is like a water pump and this is conduit or this is a pipe. The same water shall be flowing through this conduit or water pipe. So the current is going to be same throughout the circuit. The conventional current flows in this direction. The potential difference between the two terminals is V. So the conventional current, that is positive current, will flow in this direction. So if we say this is A, this is B, this is C and this is D. So we say the conventional current flows in this direction. It goes in this direction. When we say the conventional current flows in this direction, and we also know that is conventional current or positive current flows from higher electric potential to lower electric potential. So it means it is flowing. The same current will be flowing in this direction. The same current will be flowing through all the three resistors R1, R2 and R3. When we say the resistors they are in series, it means the same amount of current that should flow from all these resistors which we are saying that is there in series. When we say this is like a water pump and this is like a conduit or a water pipe, so the same amount of current will flow through R1, R2 and R3. It is not possible that is through R1 and R2 we have a different value of current and for R3 we have a different value of current. So these three resistors they are in series. Had they been combination like, let's say one more resistor R4 is like this. As we know that is current is dq by dt, that is rate of flow of charges through any cross section. So for R1 and R2 it's going to be same current. Now over here the current has an option to flow from here or some from here. So the current gets divided. Obviously the current will not be same, that is whatsoever has been passing through this R1 and R2. So now the current will not be same what has been coming from R1 and R2. The same current will not be passing through R3 or R4. Over here when the current comes over here it gets divided. Some passes through R3 and some passes through R4. So the value of current through R3 is different than the value of current which has been passing from R1 and R2. So over here we can say that is R1 and R2 they are in series. What about this? We'll come to this later on. Now let's find out the equivalent resistance to this kind of arrangement. We have R1, R2 and R3 they are in series. The conventional current is flowing in this direction. We know that is conventional current or positive current flows from higher electric potential to lower electric potential. So it means when the current is going from here to here, electric potential of A is greater than electric potential of B, and electric potential of B is greater than electric potential of C, and electric potential of C is greater than electric potential of D. That is VA is greater than VB, is greater than VC, is greater than VD. This is, we are talking about potentials, electric potentials or absolute potentials. Now we are also interested in what are the potential differences across AB, that is across the resistance R1, across the resistance R2, across the resistance R3. For this what we do is, that is as we had done earlier, so this is V, it comes over here, we have tilted it like this. So this is R1, this is R2 and this is R3. A comes over here, B is here, C is here and D is here. Resistances they are joined end to end and they are in series. Now the same current amount of current will flow through this. If we say that is potential difference across A and B, across this, across A and B, across R1, we know that is it is going to be V1. If you can compare this to our earlier example where we had talked the potential and potential differences, so the potential difference across this V1 is equal to I, current flowing through this I into R1, that is we have used Ohm's law. Similarly, potential difference across B and C, we say V2 is going to be I into R2. The same amount of current will pass through this. Resistance is R2, so the potential difference V is equal to IR. We know when we say V is equal to IR, that is use Ohm's law, then V stands for the potential difference which has been applied across a resistor R. And the potential difference across CD, if we say V3 is equal to I into R3. So potential difference is IR1 across this, IR2 across this, IR3 across this. Now we are interested in finding what is the equivalent resistance of these three resistors. The equivalent resistance means that if we remove all these three resistors and we replace them by a single resistor called the equivalent resistor, then from the same battery the same amount of current should be drawn as being drawn in this case when the three resistors or whatsoever combination of resistors they are there. So when we talk about the equivalent resistance is that single resistance which replaces these resistors and there is no change in the current which is flowing in the circuit from the same battery. So when we talk about the equivalent resistance, so it means from the same battery, we have applied the same battery over here, that is we have one single resistance, let's call it as REQ, that is EQ stand for equivalent resistance. This is V, the battery is same and the current should also be same, I. Now let's call it as A and D. So now what we have done is, in this circuit what we have cut these three resistances A and D, we have replaced it by a single resistance between the terminals, between the ends A and D, we have replaced by a single resistance, that is REQ. So obviously for this V is equal to I into REQ. If we say over here V, this potential difference across this or across this between the 2 points is same, you can take any path. So across this we know this is a battery, so this is creating a potential difference across A and D as V only. So this V is equal to V1 plus V2 plus V3. So V is equal to V1 plus V2 plus V3, as we have done in our previous case where we understood the absolute potential and potential differences. Suppose this is 3 meter, this is 3 meter, this is 3 meter. So from here to here, it is the total height is 3 plus 3 plus 3, that is 9 meter. The same thing goes with the potential differences also. So the potential difference across this and this is, let's say, IR1. This being at a higher potential as compared to this being at a higher potential as compared to this. The potential difference is IR2. The potential difference between this and this is IR3. So the total potential difference is going to be IR1 plus IR2 plus IR3. So this comes out of V1 is IR1 plus IR2 plus IR3. So this is the total potential difference. But that is equal to V only. That is battery is creating a potential difference total V across these two ends. V is equal to I into R equivalent. But this V and this V, that is same. That is R equivalent is that single resistor. It is that single resistor which replaces this arrangement, and from the same battery it draws the same current. So battery potential difference, it has to be same. So we replace this V by IREQ. So IREQ is equal to IR1 plus IR2 plus I into R3. So from here we get R equivalent as R1 plus R2 plus R3. So this is the equivalent resistance of these three resistors which are arranged in series, that is end to end. Now let's understand the parallel combination of the resistors.